In this video, I'm going to give you examples of perspective. And wouldn't you want to find a book that has all of this written down? I know, it's Ellen's Guide to Perspective on Amazon. Which perspective is most appropriate for this table? Would you choose B or C? I think C is most appropriate for small objects because it has narrow converging lines. This looks more like a large object, like a bed frame. You could, of course, use this if you need distortion in your painting, but for a realistic image, you would want these narrow converging lines for a small item. Vanishing points should generally be closer together for larger objects than for smaller ones. So if we look at this large box with a low eye level, it has marked convergence on top, so it looks like a building close by. Objects below eye level, which would be these two, appear small because we assume that eye level is about 5 feet up off the ground as if we're standing. And a medium-sized box like this one has eye level in the picture and some convergence, whereas a small box like this has a high eye level that's out of the picture and minimal convergence. Large boxes result in the most dramatic perspective because their converging lines widen the most. Small boxes appear flat regardless of their position. This one could be a house in the distance, whereas this one could be seen from a low-flying plane. In this drawing, I show you that the lines converge toward a vanishing point on eye level. And notice for the roofs that I use the top of the roof to find this vanishing point because the tops of roofs are horizontal. The eye level that we get goes through the upper part of the windows, and that's about where the eye of a person would be if he were standing right there. So the viewer is probably standing looking at this scene. And that makes sense because we see the top of the floor and the bottom of the attic. In this case, the houses converge toward vanishing points on eye level that's well above the houses. So that suggests that the viewer is in a larger house looking down at them. But even though their vanishing points are on eye level, indicating that they're all on the same level ground, it doesn't look that way. It looks like a downhill. And that's because this building and this building are shorter than the ones in front. And they should be the same size. It looks like they're the exact same house, so they should be the same size. It should come up to here. And it's this extra diminution that makes it look like they're on a downhill. Now, for the pattern for the attic, I have the plan view right here, and I drew lines to the measuring line to find these traces that mark important points on the pattern. Then these converge toward a vanishing point on eye level in that direction, but when they run into the house, they go vertically up and across to become part of the pattern. And here is the final pattern in the attic floor. How would you find the windows on the side of this building? Well, set up a measuring line here and find the traces that correlate with the placement of the windows. Then repeat that pattern over here and draw a line from the end of the pattern through the end of the building to a vanishing point on eye level. Then we can draw a line to that vanishing point, and when it passes by this line converging toward the center of vision, we go vertically up, and that's one side of the windows. This is a more difficult problem. We want to insert 4 sets of these windows onto this trapezoid. So first we have to divide the trapezoid into 4 parts, and we do that by using the blue diagonal here to find the center and the 2 green diagonals to find the lines on both sides of the center. So now we have 4 parts in perspective. Now connect the trapezoid to the windows and then draw lines to the measuring point that are important parts on the window and draw converging lines on the trapezoid that would go to the same vanishing point as the trapezoid. Then draw X's in all the vertical divisions and find the points where the X's cross the windows at important points here and here. And for the trapezoid, we have dots here and here, and we draw vertical lines through those dots in order to find this final pattern. So here we have an elevation, meaning a flat view of the vase. And the picture plane is slanted, meaning that we're looking down at the vase. This is a bird's eye view. So draw some lines toward the picture plane so we can identify these traces on the picture plane. Then, from these traces, draw lines to the vase that we want to draw, and you can see that they identify both sides of each of these ellipses. This is three-point perspective of an inclined rock. So first we need to find the three vanishing points. The purple lines go to this vanishing point up here, the green lines go to the vanishing point down here, and the pink lines go to this vanishing point on eye level. Now, to find the center of vision, draw lines from each vanishing point perpendicular to the other side. So this purple line here is perpendicular to this side, and this green line here is perpendicular to this side. And they all meet at the center of vision, which is on eye level. And the center of vision here is nearly in the center of this triangle because this triangle is nearly equilateral. That is, the three sides are almost equal. Where is eye level in this picture? Well, we don't have a clear horizon because we have this hill, although presumably the horizon is somewhat below it. We have this converging line and we have this one, and those are the only ones we can use because these are horizontal and we don't have any lines down here to use. So first, let's draw in the converging lines that we know about, these two, and they go to this blue vanishing point right here. We can finish the bottom of this front face of the box, and we know that this blue line goes to this same blue vanishing point. And when it hits this vertical line, it goes horizontally following this. And then we get to this point here, and we're not sure where it converges because it doesn't have to converge toward the same vanishing point as this house. The only clue we have is up here, the 2 points on the roof that go to this next vanishing point over here, the red one. So this line must also go to that vanishing point because it's part of the same structure, and then that gives us the bottom of the gable that also goes to this second vanishing point. So check out my book, and please remember to subscribe.